This is Artemis II. On April 1st, from Florida, a rocket rose into the sky. The Space Launch System, NASA's most powerful rocket ever built, standing over 98 meters tall, taller than the Statue of Liberty. At liftoff, it generated more than 8 million pounds of thrust, more powerful than the Saturn V, the rocket that once carried humans to the moon. And from Kennedy Space Center, it began its journey. When the engines ignited, the ground shook, the air tore, and within seconds, 4 astronauts were riding a controlled explosion into the sky. In just 8 minutes, they reached speeds of nearly 28,000 kilometers per hour, fast enough to escape Earth's gravity, with the goal of carrying 4 astronauts farther than any human has traveled in over 50 years. More than half a century after the final steps of the Apollo program, humanity is going back, not to relive the past, but to begin the next chapter. Not to land on the moon, not yet, but to prove something far more important, that we can survive deep space again. Inside the spacecraft, 4 astronauts. Commander Reed Wiseman, a former naval aviator, returning to lead humanity's next deep space mission. Pilot Victor Glover, a test pilot and the first black astronaut assigned to a lunar mission. Mission specialist Christina Koch, who once spent nearly a year in space, testing the limits of human endurance. Mission specialist Jeremy Hansen, representing Canada, becoming the first non-American to travel to the moon. This is not just a crew, it is a reflection of humanity. Different backgrounds, different nations, one mission. Once in orbit, the mission truly begins. The Orion spacecraft separates from the rocket's core stage. But the journey doesn't continue just yet. First, a critical test. Orion performs a manual proximity operation, approaching the upper stage of the rocket in orbit. This simulates docking procedures. The crew takes manual control, testing how Orion handles in real conditions. Why? Because in deep space, automation isn't enough. If something goes wrong, humans must take over. Inside the capsule, they also begin adapting to microgravity, floating, stabilizing, learning to move again. They start light exercise routines to prevent muscle loss and bone density decline. Because in space, the human body begins to weaken immediately. After the test, Orion backs away, realigns, and prepares for the next step. Then comes the moment that changes everything. A powerful engine burn, translunar injection. This is where Earth starts letting go. Orion accelerates, leaving low Earth orbit behind, heading toward the moon. Inside the spacecraft, the astronauts operate systems manually at intervals, testing navigation, life support, and onboard controls. They also continue daily exercise, using resistance-based equipment to keep their bodies mission-ready. The cabin itself offers about 9 cubic meters of habitable space, small, compact, shared. For the first time in a deep space spacecraft, there is also a proper toilet system on board, a necessity for missions that will go even farther. Because this mission isn't just travel, it's verification of every system that will one day keep humans alive on the moon and beyond. As Orion travels farther, Earth begins to shrink, the moon grows, and then they cross a line no human has crossed in decades. At their farthest point, nearly 460,000 kilometers from Earth, farther than any human has ever traveled. Inside Orion, there is a protected area, a shelter, designed to reduce exposure to solar radiation. If a solar storm hits, this space could mean survival, because beyond Earth's magnetic field, space becomes far more dangerous. And then, something happens. Loss of signal. As Orion passes behind the moon, communication with Earth is completely cut off. No contact, no guidance, just the crew, alone. Orion loops around the moon, using its gravity to bend its path. No landing, no descent, just a precise, high-speed flyby. Every movement is calculated, every system monitored, because this is rehearsal for the missions that will follow. After looping around the Moon, Orion begins its journey home. Earth slowly grows larger again. Inside the spacecraft, the crew continues monitoring their physical and mental state, reaction time, focus, fatigue, because this mission is also studying how deep space affects the human mind. As future missions aim to make lunar travel more frequent, almost like missions to the International Space Station, this is preparation for living beyond Earth. As Orion approaches Earth, it travels at merely 40,000 kilometers per hour. When it hits the atmosphere, friction turns air into plasma. Temperatures outside reach nearly 3,000 degrees Celsius, but inside the capsule, around 24 degrees Celsius, controlled, stable, alive. During Artemis I, the uncrewed mission, NASA observed unexpected heat shield wear. Not a failure, but a warning. Now, this is the real test, because this time, there are humans on board. After surviving re-entry, Orion deploys parachutes, slowing down rapidly, before finally splashing into the Pacific Ocean. Waiting below, recovery teams, US Navy ships, helicopters overhead. Divers secure the capsule, the hatch opens, and the astronauts return to Earth. So why go through all this without landing? Because this mission is about testing, not just machines, but humans, life support systems, radiation exposure, manual control in deep space, navigation without constant communication, re-entry at lunar return speeds. If Artemis II succeeds, it proves we are ready to land, ready to stay, ready to push beyond the Moon. For decades, the Moon was a place we visited. Now, it's becoming a place we return to, not as explorers passing through, but as a species preparing for something bigger. Artemis II is not the destination, it's the test, the bridge between Apollo and the future. And when those astronauts look back at Earth, they won't just see a planet, they'll see home, small, fragile, and just the beginning.